Hello, hello, it is I. Greetings! Hi, how y'all doing? I can see there's no one. Kind of sad, but not a problem. Today, you've already read the title, you've already seen the thumbnail, I'm going to do some coding in Godot, which we're going to continue where we left yesterday. I was coding yesterday, but then I was rudely interrupted by a blackout. So, without further ado... Oh, wrong screen. Give me a moment. Give me a moment. Give me a moment. There we go. No. Done. There we go. This was the world you were working on. I was interrupted last stream, which was yesterday, when I was working on grid. I set up the grid. I assign the positions. When I hit generate maze, I'm going to make this function later on, you know, build the walls and generate the actual physical maze. But for now, it's just creating these balls to create representation. I'm gonna pause this song. To create representation of where the maze rooms will be, and then what we were working on last time I was here was when I press clear nodes, it should clear the whole thing, but it only clears half of it and gives me a whole lot of errors. A whole lot of errors. Index p index is equal to 13 is out of bounds. Wait, 13, 14, 15. Wait, am I just like, is it skipping numbers as it counts? That could be a possibility of what's happening here. We go into the scripts and in clear nodes. For I and get child count, we remove a child. Oh, oh, I see what's happening. So, to put it visually, you have a list of objects. You have object 1, 2, 3, 4, 5. If you remove object 1 and then want to remove object 2, when removing object 1, object 2 therefore becomes object 1, and you're instead removing object 3, and then you leave object 2 without deleting it. So how I see we could do this, instead of deleting I, we could remove 0, which is always object 1, so that all the objects just come into being object 1 and get deleted procedurally. If we do that, and then set up grid, generate maze, and then clear, et voila, and no new errors. Set up grid, gen maze, clear nodes. Perfection. Now to wait, that feels like a lot. I'm gonna be honest, that feels like way too much. 1, 2, 3, 4, 5, 6. Wait, it's a 5 by 5 grid, which should be 25. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, how about I just do a 2 by 2 grid? That should give me a clear and good representation. That's still way too lot. Something's not adding up. Oh, I think I forgot to save. That was a problem. No. Clear nodes. Then we save it. Wait, did I use... Okay. In setup grid, we use the grid size X and Z to place the nodes. And then we use the nodes to place the node representations, which are the balls. Oh, hello, one viewer. How you doing? You can chat if you want to. If you don't want to, it's okay. Right now, I'm working on a maze generation script. Right now, it's just placing things in a grid and not doing anything else. But as it progresses, I'm hoping it does more and more. So right now, I need to find out why it's not adjusting grid size. I think it's... So wait, if I save it and then say setup grid and gen maze, but if I turn off the world, open it again, then now setup grid and gen maze, it's just 2. Okay, this makes sense. This actually makes sense. When I change this, I need to turn off the world and then reopen it, exit it and then reopen it so that it can be updated. Things are working as they seem. So let's do it again. Set up grid, gen maze, clear nodes. That's working perfectly. Now I do want to remove this because I think this is also causing some lag. No, the instancing is causing the lag. Eh. You know, I don't think we really have to worry about that right now. I can just continue on working on different things. What should I work on right now? Let's look at the node. Connected node index, yeah. So each node, how I'm imagining this code to work is, there's two ways to do it. One way is to have each node have the index of the node it is derived from. So when you're going down a maze, there's always going to be a previous maze room, a maze square. So one way I can do it is always have it memorize the previous maze square. This is easy since it will only need one variable, but in order to see whether you can move through the maze, you're going to always have to check this code node index on the next node you're trying to move to before you can say can it go or not. So another way I could do it is I can have every node know the list of every node it can move towards. This will... Okay, so the entry node, and then we have the second node, then the entry node will have to remember the second node's index. The second node and the third node, this is where it kind of gets a bit complicated, complex. The second node needs to remember the third node and the first node so that it knows it can go back into it. This is what we're mostly going to use for mesh generation, but right now, I don't think this is as important because this will help us make things easier in order to know where we can go to, but it doesn't make it easier enough that we have to create a system to list everything as an array. So all we have to do is just delete this, and then instead of connected node indexes, I can say previous node index. I think that would work perfectly. Type node. No, int. It's an integer, yeah. We could do that. Now we're going to have to create, yes, we're going to have to actually replace the generate maze part now. So the generate maze code is what's supposed to generate the actual how each node connects to the next one, where the wall should be and whatnot. So the system I'm thinking about using is one I saw for a Minecraft redstone build. It's a pretty simple, like extremely simple implementation where you start from one node and then check every node around it to see which nodes are open. You choose randomly between those, and then you check again to see which around it which nodes are open, and then you pick between those, and then you just keep going until you are in a corner where you can no longer create any more routes. And once you enter that situation, you go back to the last detour you took, and then repeat the process over and over again until you hit the end. And then the rest can be filled progressively. So in order to do that, I'm still going to have the generate maze generate the representations, but after generating the representations, here is going to be a for loop, I think. How can we implement it? We could put a function inside the node class itself that checks for everything around it. I think that would be a good thing to do. Export func. Check neighbors. And then the neighbors are going to be check neighbors will need the entire width and the height of the object to be able to calculate that, so it would be easier to do that here inside maze. So for this loop, for now, we're just going to say while. While would get us, we could say while current node is not exits node, run this code, which, yeah, that would work. For now, let's just not loop it, but instead we're going to need a beginning node and an end node. So in the node, we're going to have type exports. I could either have it as an integer, which is either 0, 1, or 2, 0 being regular, 1 being starting node, and 2 being ending node. Or I could have it as a string, as I feel like the integer will probably be much easier. Integer var int type. So what I can do here now is let's make this by default equal to 0. And once we set up grids, we can say nodes 0, which is the first node placed, dot type equals 1, which is the starting position, and say nodes dot size, which is a function, -1, which gives us the very last node ever placed, and then replace that type into 2, which is the ending position. And now here, let's just, first of all, we're going to need to find the node type beginning, because I want to make sure that I can change later in code what the beginning node is, and it will find it automatically. Like if we do current node equals nodes 0, for now this is perfect, it will work perfectly. But we're not trying to work for the now. We want to make sure this will work whenever. So I'm going to have this loop throughout everything while let's have a variable here, var type equals 0, the type, and it is an integer. Let's have that placed. Let's say while type equals 0, we run this code. Forgot this ain't JavaScript. And then inside the while loop, we can say, we can also just var I. I feel like a for loop would be much easier for this, honestly. For I in nodes.size if, yeah, let's also have the variable for cur node, assign it. Let's make it a class. No, that doesn't feel like the right way to do it. Anyway, if nodes I dot type equals 1, then we need to break the script, the loop. Can that break a loop inside GD script? I'm gonna need to Google that. How to break loop in GD scripts. It might actually be break. Where's my mouse? Oh, okay, so I could test it, like, we'll print here stop, and here we'll print running. So now let's make running over here. So it's going to print running multiple times until it hits stop, then it's going to stop. But since the start node is the first ever node inside the list, it should just print running once and then print stop. If we try it, set up grid, there, perfect. Running once and then stop once. So we know this works. So that's weird. The fact that you don't need parentheses in if clauses and for loops, it's pretty weird. Anyway, we're going to need to find a way to, current node is equal to nodes I. This assigns the type begin one onto current node, and then for current node we're going to have to search through the neighbors. In order to do that, we're going to need to know exactly where current node is inside the grid. We can do that using the I. So what is a mathematical representation of this? I would like to put it as an x plus y and whatnot. I is equal to x plus z times x size. This is the current function we're using to find the indexes of all z nodes. So how do we reverse that? How do we find both x and z? Give me a moment, I'm going to need to have to go. Hello, I'm back. We had a few chatters. Are you sure it's viewers and not viewer? Ha ha ha, my guy. That is very funny. Ha 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 ha. The former bear says, hello, hi. I am sorry I missed you. If you return, how are you doing? How was your day? I'm gonna go back directly to what I was doing now. What was I doing? Wait, I seem to have had an error, so I want to make sure that's not gonna be something. When I save it, when I press setup grid, no error, no error, no error. Setup grid, gen maze, clear nodes, no error. We good, we chillin'. So where were we? I think we were trying to see the neighbors. Yeah, we were the formula, yes. So first of all, what I'm going to need to do is to find in what column in what row it is. So how I assume this works is it goes like this, and then like this, and then like this, like this, like this. So every a row needs to be complete before the next row is checked. So, and each in one row, each column is checked one by one. Therefore, what we need to find out is in what column we are. Once we find out what column we're in, we can find out exactly what row we're in. I think that's what we can do. So, formula here, we can say I divided by x size. This gives us a number that is higher than the current column we're in, but that is also less than the next column we could be in. So this is z is less than I divided by size, which is less than z plus 1. So all we need to do is the floor of this, and that gives us the column. So new variable cur node grid 2D index is equal to, I'm going to place it in a vector 2 because why not? That will make it much faster. We seem to be like listing the z and then going to the x. So I'm going to say the x is the floor of current node divided by z grid size. That gives us that, and then we're going to need to find a way to find the z of this current Note, how do we find the z? If we come back here, right? If we come back here, we can now subtract I divided by x size by z, and we can remultiply that by x size to be back into integer form, and that is all we need to do in order to find the row, the colon. So let's try to simplify this code. I minus z divided by x size, which in this case is actually x divided by z size. Let's replace all, cause why not? Formula again. The index minus x. Is it divided by? It's times. It's times. Here. Kernode.index, which I also forgot to do right here. Minus, inside brackets, x times z grid size. This should give us the identifier x isn't declared in this scope. I seem to be doing something wrong. Oh, okay, so x needs to be this. Let's see what that gives us. We will also print current node two-dimensional index. There seems to be a problem. Invalid index 0 on base array in line 28. Line 28 is here. Node 0 dot type is equal to 1. I think the problem is we haven't set up the grid, we haven't generated the maze, and we haven't cleared it. Something's off. Oh, no, I think that's correct. So instead of 0, we make it something like 5, and then set up grid, generate maze, 1, 0. That's actually perfect. We make it into 4, it's going to be 0, 4 instead of 1, 0. Set up grid, gen maze, 0, 4, perfect. Clear all nodes. All nodes. That is exactly how I wanted it to work. Now, since we have the two-dimensional index, we can start translating, we can start searching for all the 4 squares of the maze around it. So let's give them their own node representation, their own variables, because why not? Above node is equal to can this be done? Wait. Node to the index. What is above inside this? Above is x. I'll take x as above. So node 2d index dot x is equal to 0 question mark, not equal to 0. I really hope this works actually. I love this script whenever I do it in JavaScript. I hope this works here as well. Is equal to cur node 2D index minus vector 2 1, 0, if not equals null. Then we say that's not working. That's a bit disappointing. I'm gonna be honest, I'm a bit disappointed. I'm gonna see if I can do it like if statements inside variable declaration. I want to know what it's called. It seems like not enough. So I'm just going to do what's the fastest way to do this? Set 4 variables whilst also initially checking if those variables are even settable, because if by checking if the current node lies upon the boundaries. Let me turn on the light. It was getting a bit dark. Da -da -da -da. What can I do? I could set a series of if clauses to check whether every criteria is met, but doing that has the issue that it's going to be a lot of if clauses and it's going to be inside of a loop. So I'm going to need something fast and short. How do I do that? I could have a switch case, check if it lies upon the borders, but that doesn't, you know what? If clauses using else seems to be the best way to take this. If dot x does not equal 0, then we assign above node as cur node 2D index minus vector 1, 0, but we're also going to need a way to... What if I just make nodes uh, a two-dimensional array? That would actually help a lot. Is that even possible? 2D. We could always do the classic way of, assigning an array within an array. So nodes.append an empty array, obviously, and then nodes x is the above one, right? Nodes x dot append this node, and then wait, let's like take that out for a moment. The indexes are going to remain so that it won't need the two-dimensional grid in order to know whether whether it's compatible or not. We'll just have the indexes there, the one-dimensional indexes there, to see if that can be used in any way useful. If it can't, it will be deleted. It's okay. But right now, if we make it a two-dimensional node, things would be much easier, honestly. So let's continue. Function generate maze where I in node size dot size obviously I'm going to have to change this into for x dot nodes dot size, and then inside for z in nodes x dot size, and then a boop nodes x z dot pause. Oh, right. And this works, right? So again, I'm going to have to copy this, place it here, create space over here, and here I'm going to say node x of z dot type is equal to 1, then cur node is equal to node xz. In current node 2D index, I won't need it anymore. It would be useful. Instead of just doing that, we could just say we could assign this variable here with current node, and then when assigning current node, we can assign current node 2D index as a vector 2 of x comma z, which makes it extremely easy. And say if current node 2D index dot x is not equal to 0, and then we could have a variable called accessible nodes, and this accessible nodes will become an array, just a one-dimensional array. Doesn't need to be two-dimensional. And say if cur node is not the absolute top, then accessible array nodes dot append nodes current node to the index dot z. That's going to be completely the same, but here it's going to be x plus 1. Does this work? Current node 2D index isn't declared in the current scope. It is right here. Doesn't need a semicolon. I'm gonna see if I can rewrite it again, and if it autocorrects me here, and we won't have to deal with the issue. Kernel 2D index.x -1 instead of +1. Kernel 2D index.z, and that gives us the node exactly above, which is a negative in the x direction. Wait, but if we go here, we've assigned above is towards x direction. Now all I have to do is like flip it, but then if I flip it, it feels wrong. So when I do it like this, positive x is towards the right and positive z is towards positive z is towards the bottom. So I'm just going to do this. Do this 4 times and say if z is not equal to 0, but it doesn't have to be according to the 3D dimensions of the world. It has to be about how I assign it. And I assign it as the least value of x and z are the top left corner, right? So this is going to be towards our top, which x is to the right and z is to the bottom, which does line up. But instead of doing it this way, we're doing it this way. So if x equals to 0, we're going to need to have left instead of above. So I'm just going to rename this. I don't even have to rename it. X -1. Why am I worrying about orientation anyway? None of this depends upon orientation because we have this case and then we just have to worry about that and nothing else. X +1 and z +1. Here we are going to have to check if x is not the absolute positive this could be. So we got x grid size and we got z grid size. What I need to check if x is equivalent to x grid size -1, because remember, when dealing with coding, you don't begin from 1, you begin from 0, so everything needs to be subtracted. Z grid size -1, and then makes this a z. And then I guess that is all. I feel like that is all. After this, why not just print the accessible nodes? For now, let's just, we should have only two nodes when we run this script. Saved everything. We set up the grid. We generate the maze. Oh, there's the lag. Generate maze. Oh, there wasn't a lag, but we got an error at line 51. What happens at line 51? If cur node 2D index.x. How about I just, just delete all of that and then print the current nodes. But if I save, I can't rewrite all of that. So instead of doing that, I'll just do, what I have to do, which is boring, but, we'll do it. And then, damn, bless me. We're just gonna print the current node 2D index to see what type of value we're dealing with. Setup grid, generate maze. We get a null type, which is weird. Clear nodes, they have everything. Don't really know how to deal with this. Hello, viewer. How you doing? You can chat if you want to. Don't chat if you don't want to. I'm hoping you're having a great time. We're going to have to think about how we do this. Current node 2D index I've said is a vector 2. Maybe what if we assign it as a vector 2 here? Then obviously it's going to be a vector 2, but is it going to have the values I am looking for? Setup grid, generate maze. It's a 0, 0, clear nodes, just for the sake of it. But 0, 0 would have always been a 0, 0 if we make this 1 now. Oh. Oh. This actually kind of makes sense. Node 0, 0 is type 1, and node z grid size minus 1, actually x grid size minus 1, z grid size minus 1 is equal to 2. If we save that, but instead if we just make this 1, then we set up grid generate maze, it's still 0, 0, which is an issue. How about we print here again to check if there's anything going on here, so that's significant. Jendurasen, because why not? I have no idea what that means. I don't even think it means anything. Setup grid, generate maze. It does not say Jendurasen, which makes me think it's not even checking. So I'm just gonna put this here. Another one here. Going to name this Jendurasen Og and this Jendurasenet. Save it. Setup grid. Generate maze. It does not do either, which is worrying. How about I just, rent the array itself, notes, because it might be a complete like two-dimensional array issue thingy. Setup grid and then print it. It's empty for some reason. It shouldn't be empty. Oh, this needs to be here. Maybe that will fix it. Setup grid, gen maze. There we go. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. What's 6 times 8? I'm gonna pull out the calculator because I don't feel like doing maths right now. 6 times 8 equals 48. It's 5 and 5. It shouldn't be beyond 25. Why is there above 25? I for z and z grid size, which is 5. Oh, which is 5. This is being run 5 times. First, we create a new node preset dot new, which instances it. Then we give it a position. We calculate its position. Then we give it its index. Then we assign it. We append it onto nodes. But for some reason, the first node is assigned over the expected value, and then the other x's are not assigned at all. Wait, I said 5, so that's technically 6. So it's going to be 1, 2, 3, 4, 5, 6. What's 6 times 6? That's 36. But that is not the same as 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 6 times 8. That's not even close to being 6 times 6. That's 36 is 48. It's above what we expect, what we need. So something else is going on. What? But what? Alright, it's also getting late, so I'm just gonna solve this issue and then I'm gonna end the stream. I feel like that's fair enough. So first of all, the issue that it's only saving onto, let's clear all the nodes and then clear all of this. Set up grid, set it up twice. We set up grid once, we generate maze. And what the hell? Ooh, I see. I don't think we're clearing the... When we clear nodes, we only delete all the children that have been added onto the objects. We're not actually clearing the nodes. We're clearing the representation of them, which is not that hard to do, because all we have to do is... Now, I'm gonna just do it before I delete the children. Nodes is equal to just an empty array. That's all I have to do. Clear here, clear nodes, set up grid, generate maze. And did that work? They're stacked within each other like crazy. No, yeah, that's about right. That's about right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. That's absolutely perfect. So this is working. We know that now. And it said Gendurasen, which is perfect. It's found the node itself, and it said 0, 1, which is exactly what we're looking for. 0, 1. So now what we can start doing is deleting these prints. What's the error here? Cannot take index z on vector 2. This has to be y, because we're recalling it from a vector 2, not z. We didn't assign the variables ourselves, so we're going to have to play by the rules of the editor. Yes, change all the z's into y's, Save it. We get a few errors. Nobody cares. Setup grid. Wait, first of all, let's just clear nodes just to be safe. Setup grid. Gen maze. Oh, 3 references. That's exactly what we expect. Let's clear the nodes. Let's make it 1, 1. We should expect 4 references. Setup grid. Gen maze. 4 references. Perfect. Let's clear all the nodes. Let's do 0, 0. Setup grid. Gen maze. Only 2 references. Perfect. Only 2 references. Clear notes. I think that is all we are going to do today. Thank you for everyone who was in the stream, which is now a lot of people, and thank you to all of you who are watching the VODs. It means a lot. I actually enjoying this, and I would like to do it even much more. So, to all of you, see you tomorrow, I guess.